Joshna from the Agora Math Circle, and today we are going over Senior Beginner Session 4, Fractions. So if you remember in Session 3, we learned about counting and the principles of counting, like least common multiple and greatest common divisor. So we will be applying some of those principles in this lesson. So for fractions, we are going over what is a fraction, simplifying fractions, comparing fractions, multiplication of fractions, exponentiation, division by a fraction, adding and subtracting fractions, and finally, mixed fractions. Alright, so let's start with what is a fraction. If we let a equal a number and b equal a non-zero number, then the fraction a over b equals a divided by b. So this little line right here is called the fraction bar, and you'll have a, fraction bar, b. So a over b equals a divided by b. The number on top is called the numerator, and it's the amount of parts you have. And the number on the bottom is called the denominator, and it's what you're dividing the parts into. So let's look at some examples. 2 over 3. So notice how I said it's a over b. You can say 2 over 3. And you can say 2/3. It means the same thing. And it ultimately means that you're dividing 2 by 3. So 2 divided by 3. So there are 3 ways to talk about a fraction. You can say this is, for example, this, 2 over 3. You can say it's 2/3 because there's 1/3 and then there's 2/3. And then you can also say it's 2 divided by 3 because, as you can see right here, it equals the same thing. So let's look at some principles. Dividing by 0. So if a equals a non-zero number, then 0 divided by a equals 0. Let's look at an example. 0 divided by 1 equals 0. But don't confuse this with dividing by 0. So for example, 1 divided by 0, that equals undefined. So reason why is that you can divide 0 into many parts. Like you can divide 0 into one part, it would just be 0 in each value. 0 divided by 2 parts would just be 0 and a 0. But you can't divide a number into 0 parts. It doesn't really make sense. So another easy way to remember that is by thinking of 0 like an egg. So when you have 0 over 1, you have the egg on top of the table. And since it's on top of the table, the egg won't fall or crack. But then, in here, 1 over 0, the egg's on the bottom of the table. So it can fall and crack. So it makes the answer undefined. So now into self-division. So if a equals a non-zero number, then a divided by a, or a divided by self, equals 1. For example, 4 divided by 4 equals 1. You keep going. 6 divided by 6 equals 1. 1 divided by 1 equals 1. 0 divided by 0 does not equal 0, but you'll learn that much later. So, 0 divided by 0 does not equal 1, and you'll learn that much later. So dividing by 1. If a equals a number, then a divided by 1 equals a. For example, 10 divided by 1 equals 10. 12 divided by 1 equals 12. 4 divided by 1 equals 4. Okay, keep going. So now dividing into negation. So if b is a non-zero number, then negative a divided by b equals negative a divided by b in parentheses. So it's pretty much saying that the whole fraction is going to be negative. So if the numerator is negative, that makes the whole fraction negative. So, an example, negative 3 over 5 equals negative 3 over 5 in parentheses. It's pretty much saying that this whole fraction is going to be negative. So just when the numerator is negative, the whole fraction, it also means that the whole fraction is negative. And we can do the same thing with the denominator, dividing by a negation. So a divided by negative b. It pretty much equals the same thing. So it equals negative a over b in parentheses. So when you have a negative in either the numerator or the denominator, not and, that means that the fraction, the whole fraction, is negative. So, for example, 5 over negative 4 equals negative 5 over 4 in parentheses. So now, negation dividing by negation. So, negative a over negative b is going to equal a over b. So we can think about this like when a negative times a negative equals a positive number in multiplication. Well, when you divide a negative number by a negative number, the answer is a positive number. For example, negative 6 over 5 divided by negative 5 equals 6 over 5. So the negatives cancel out. Alright, so let's move on to simplifying fractions. So first of all, what is simplest form? Well, the simplest form of a fraction is when the numerator and denominator have no positive common divisor besides 1. So we'll learn about that in the example. And basically when we want to simplify or reduce, they mean the same thing, simplify or reduce a fraction, we're going to divide the top and bottom by the highest number that can divide both numbers exactly. So let's look at some examples to clarify. I want to simplify the fraction 24 over 108. So I can do this either the really quick way and just find the GCF, or do it a little slower way and break it down. So, and just do it by common divisors that I know of. So I'm going to do it the second way. And I'm just going to find a common divisor that I can divide both of these two by. So 24, let's think. I know I can divide it by 2 because 24 is even. So 24 divided by 2. And then whatever I do on the top, I have to do on the bottom. It's really important. Whatever you do on the top of the fraction, you have to do at the bottom. So dividing the top by 2, that means I have to divide the bottom by 2. So what is 24 divided by 2? That is 12. So I have 12 over, and then what's 108 divided by 2? 54. Alright? Now I know that this isn't simplest form because there are more common divisors between these two numbers. So let's keep thinking. What can I divide 12 by? Well, I know that I can divide 12 by 6. I know that I can divide 54 by 6. So let's do 6. Divide by 6 on top and divide by 6 on the bottom. So 12 divided by 6 equals 2. And then 54 divided by 6 equals 9. And let's see if I can divide this even more. Well, I can't really divide 2 by anything other than 2 and 1, and we're not going to do 1. And 9, I can't really divide anything, I can't divide by 2, and so that's it. So we know that 2 over 9 is our simplest form of a fraction. So this is kind of the longer way to do it. You can just use common divisors. Or what you can do is find the greatest common divisor and just do it in one step. So I just know that 24 is divisible by 12, and that equals 2. And then 108 is divisible by 12, and that equals 9. And I just got straight to my answer, 2 over 9. Another way you can find out the common divisor is just by multiplying this by this. So 2 times 6 equals 12. We know that 12 is the greatest common divisor. Alright, so now let's look at another example. So let's think of another fraction that we want to simplify or reduce. I'm thinking maybe 45 over 105. Alright, so I know that 45 is divisible by 5. So if I divide the top by 5, I have to divide the bottom by 5. So that equals 9. And then I know that 105 divided by 5 equals 21. And I know I can divide this even further. So divided by 3 equals 3 over 7. And that's all I can go. So 45 over 105, I can simplify that to 3 over 7. Now again, you can do this much quicker by just doing the greatest common divisor. And I can find that out by doing 15. So 5 times 3 equals 15. So I know that 45 divided by 15 equals 3, and 105 divided by 15 equals 7. So now let's move on to comparing fractions. So let's say you have two fractions with the same denominator. The only way you can compare them is by looking at the numerator and seeing which one's bigger or smaller. For example, let's look at 4 over 9 and 7 over 9. Which one's bigger? Well, let's only look at the numerators. We know that 7 is bigger than 4, so we know that 7 over 9 is bigger. So another way you can think about it is like pizzas. Let's say you have a pizza with a 9-slice pizza with 4 slices left, and another 9-slice pizza with only 7 slices left. Which one's bigger? The pizza with 4 slices or the pizza with 7 slices? Well, obviously, it's the pizza with 7 slices. So that's why you only have to look at the numerator when comparing fractions with the same denominator. So which one's bigger? 7 over 9. So let's do that. But what if they have different denominators? For example, 3 over 8 and 5 over 12. Well, we can't just ignore the denominators. That's what makes them different values. Well, just how we just learned that if you divide both the top and bottom by the same number, we can change the value of a fraction. We can multiply the top and bottom by the same number to also change the value of a fraction. So what we can do is multiply the top and the bottom, and try to make the bottoms the same. So how am I going to do this? Well, let's think. What can I multiply 8 by? Well, let's just say I multiply 8 by 3. And that equals 24. And then what am I going to multiply 12 by? 2. And what does that equal? 24. So now I just made the denominators the same. Now I have to do whatever I do at the bottom at the top. Same here. Whatever I have to do at the bottom to the top. It has to be by the same number. So since I multiplied the bottom by 3, I'm going to multiply the top by 3. And what is that going to equal? 9. And then multiply this by 2. What does that equal? 10. So now since the denominators are the same, I only have to look at the numerators and see which one is bigger. Well, 10 is bigger than 9, so I know that 10 over 24, or 5 over 12, is bigger. So when comparing, I know that 5 over 12 is bigger than 3 over 8. Next, let's go over multiplication of fractions. So, if we let b and d equal non-zero numbers, then a divided by b times c divided by d equals a times c over b times d. Make this bigger. So it equals a times c divided by b times d. So what you're basically doing is multiplying the numerators straight through and multiplying the denominators straight through. So there's 3 steps in multiplying fractions. The first thing you do is multiply the numerators. Next, you multiply the denominators, and finally, you simplify. Now this is really important. So let's look at some examples. 1/3 times 9 over 16. So what you want to do first is multiply the numerators. So what's 9 times 1? 9 times 1 is just 9. And then what's 3 times 16? That is 48. Sorry. That is 48. So now we know that the answer is not simplified because I know that I can divide 9 and 48 by 3. So what's 9 divided by 3? That's equal to 3. And then what's 48 divided by 3? That's equal to 16. So our final answer is going to be 3 over 16. So it's always important to make sure your final answer is in its simplest form. Now let's look at our next example. 7 over 9 times 5. Well, the first thing we want to do is turn this into a fraction. And how do we do that? Well, since we know that any number divided by 1 equals the number, we know that 5 divided by 1 equals 5. So I can just write a little divided by 1 under. So now we know that it's a fraction. Now we can just multiply 7 times 5, which equals 35. And then we can multiply 9 times 1, which equals 9. And this is our final answer since we cannot simplify this even more. So that's all for multiplying fractions. Now let's move on to division by a fraction. So before we do that, let's learn about reciprocals. So the reciprocal of the fraction a over b is b over a. So a over b to the negative first power equals b over a. So what you're doing is basically flipping the fraction. Alright, so let's look at an example right here. It's really small. But the 4 over 71, we want to find the reciprocal of that. So we just switch it. So we just do 71 over 4. And that's our reciprocal. So this is important because we need it for dividing fractions. So if we let b, c, and d equal non-zero numbers, then a divided by b divided by c divided by d equals a divided by b times d divided by c. Or a over b divided by c over d equals a over b times c over d. So we found the reciprocal of this fraction right here and multiplied it. And that ultimately equals a times d over b times c, since we already learned from multiplication. So there's 3 steps. First, find the reciprocal. Next, multiply. And finally, simplify. So let's look at some examples. We have 1/2 divided by 1/6. So the first thing we're going to do is find the reciprocal. And that's always going to be the second, or the divisor. So let's do 1/2 times, and what's the reciprocal? We just switch it, so that's 6 over 1. And now we're just going to multiply how we just learned. So we do the top, and we do the bottom. So that's 6 over 2. And then we can simplify this. And since we know that 6 divided by 3 equals, 6 divided by 2 equals 3, and 2 divided by 2 equals 3, we know that the answer is 3 over 1, or just simply 3. You can also think of it as 6 divided by 2, which equals 3. Now let's look at the next example. 1/8 divided by 4. So since we already know from our last examples in multiplication, we can just put another 1 under, since we know that 4 divided by 1 equals 4. But we want to find the reciprocal, right? So what's the reciprocal of a whole number? Well, we just put a 1 over that. So 1/8 times 1 over 4. So when finding the reciprocal of a whole number, you're just going to put a 1 on top and the whole number on the bottom, since we know that every whole number has a whole divided by 1 under it. Alright, so now we're just going to multiply, and that equals 1 over 32. And that's our final answer. So we don't have to simplify for this one. Now let's move on to exponentiation. So if you let a and b equal non-zero numbers, and n is an integer, then a divided by b raised to the nth power equals a to the nth power divided by b to the nth power. So we're pretty much applying this exponent to the top and the bottom of the fraction, or the numerator and denominator. So for example, we have 3/4 to the second power. So another way of writing this is just 3/4 times 3/4, and then the way of writing the way that we just learned is 3 squared over 4 squared, and that equals 9 over 16. And that's our most simplified answer. So our answer is 9 over 16. So we're just applying the squared to the 3 and to the 4. But this also works with negative exponents. So if a and b are non-zero numbers, and n is an integer, then a divided by b raised to the negative nth power equals b divided by a to the nth power. Now why does it switch? Why is it b over a? Well, let's look at an example. A divided by b raised to the negative second power equals, well, since we know that's a negative exponent, we know that we have to put a 1 over and then the actual value, so over the positive exponent. So we put a over b to the second power. Then we know that an easier way to write that is 1 divided by a squared divided by b squared. So applying this. And then, since we know from dividing fractions, we have to do the reciprocal of the divisor, we know that it's 1 times b squared over a squared, which just equals b squared over a squared, and another way of writing that is b over a squared. Just like here. So let's look at an example. We know that 2 divided by 3 raised to the negative third power is just going to be 3 divided by 2 raised to the third power. And then what we do is just apply this 3 to the top and to the bottom. So what's 3 to the third power? That is going to be 16. Oh, sorry, not 16. That's going to be 27. And then what is 2 to the third power? That is going to equal 8. So our answer is 27 over 8, and that is our simplified answer. Now let's move on to adding and subtracting fractions. So, for adding subtractions, there's 3 steps. First, make the denominators the same. Next, add the numerators and put over the same denominator that you got. Then finally, you have to simplify. For example, let's look at 1/4 plus 5/12. So first thing we're going to do is make the denominators the same. So I know that a least common multiple between 4 and 12 is 12. So all I have to do is multiply 4 by 3 and 1 by 3, and I'll get 12 as a denominator. So let me rewrite this as 3 over 12 plus 5 over 12. And now that the denominators are the same, I just have to add the numerators up and get the final answer. So that's 8 over 12, and then I need to simplify. So what can I divide this by? 4. Divide this by 4, and I'll get 2 over 3. And 2 over 3 is my final answer. Let's look at an easier question. What's 1/3 plus 1/3? That's easy. The denominators are already the same, so I just know the answer is 2/3. Alright, so now let's look at subtracting. So, when subtracting fractions, there are also 3 steps, and they're very similar to adding subtractions. First thing you do is make the denominators the same. Next, you subtract the numerators and put it over the same denominator that you got. Finally, you simplify. Let's look at an example. What's 1/2 divided by 1/6? So least common multiple between 2 and 6 is 6. So all I have to do is multiply 2 by 3, multiply 1 by 3. And then I'll rewrite this as 3 divided by 6 minus 1 divided by 6. And what is that? That is 4 divided by 6. I can simplify that into 2 divided by 3. And finally, let's look at 4 divided by 3 minus 1 divided by 4. So, 3 divided by 4 minus 1 divided by 4, or 3/4 minus 1/4. And since the denominators are already the same, I only have to subtract the numerators. So that makes 2 over 4, and to simplify that, it's 1/2. And that's our final answer. So that's how to add and subtract fractions. Finally, let's go over mixed fractions. So a mixed fraction is a whole number and a proper fraction combined. For example, we have 1 plus 3 over 4, which equals 1 and 3 over 4, or 1 and 3/4. Another example is 3/4 plus 1/2. So first, you want to turn this into have a common denominator between these two fractions. And I turned it into 4, so I know 3/4 plus 2/4 equals 5/4. And from that, I knew that the mixed fraction is 1 1/4. So how did I know? Well, what I basically try to do is find out how many whole 4s are inside 5 out of 4. So what I did is divided 5 into 4. So there is I know that there is 1 4 out of 4 inside 5 out of 4. And then whatever's left, or the remainder, is just 1. So then I know the remainder is 1/4. Another way of thinking about it is, what can you add? So 5/4. Let's break that down and find how many 4 out of 4s are inside this 5 out of 4. Well, first we got 1 out of 4 out of 4. And then after that, we just have 1 and 1/4. So since we already know that 4 out of 4 equals 1, you just cross that out and equal 1. And that's just 1 plus 1/4. So the whole mixed fraction is going to be 1 and 1/4. Now, there are 3 types of fractions. The first fraction we know is a proper fraction, and that's when the denominator is bigger than the numerator. For example, 3/5. The next fraction we know is an improper fraction, and that's when the numerator is bigger than the denominator. So 9/5, or 9/5. Finally, from this improper fraction, we can make a mixed fraction. So 2 1/3. So let's think, how can we make 9 out of 5 into a mixed fraction? Well, first let's find how many 5 out of 5s are inside 9 out of 5. So I'm going to divide 9 by 5. And I know that it's going to be 1 with the remainder of 4. So I'll put the remainder right here, and I put the final fraction at the bottom, 5. So our mixed fraction from this improper fraction of 9 out of 5 is 1 4/5. So that is mixed fractions. Alright, so now that we know about fractions, we can do some challenge problems. To begin, so 2 600 milliliter or ml pitchers contain orange juice. One pitcher is 1/3 full, and the other is 2/5 full. Water is added to fill each pitcher completely. Then both are poured into one large container. What fraction of the mixture of orange juice and water is orange juice in the large container? So, the first thing we want to do is find how much orange juice is in each pitcher. So, to find that out, I'm going to multiply the total amount of milliliters in each pitcher times the amount that's full, which is 1/3. So this is saying that 1/3 of the 600 milliliters is full. And what do I get? 200 milliliters for the first pitcher. I'm going to do the same thing for the second pitcher. 2/5 of it is full with orange juice. So 600 milliliters so 600 times 2/5 of the container that's full equals 240 milliliters filled with orange juice. Now it says that they're going to add water to the rest to fill the pitcher completely. So what we can do is either find out that 2/3, whatever's left, so 2/3 of the 600 is going to be water, and 3/5 of the 600 is going to be water for both containers. So what we can do is find that out and add that, or we can just simply say that 600 and 600 is going to be filled with orange juice and water. So first thing you want to do is find out how much orange juice is going to be inside the container. So already know that we're adding 200 milliliters from the first pitcher and 240 from the second pitcher. We can just add them up. Now we're not done, because there's also water in the mixture, and we want to include that. So for our bottom, we are going to add whatever's in the whole container, in the whole large container. So it's not only orange juice, but also water. And how much water? Well, isn't it going to be 600 minus 200, which means that it's 400 milliliters in the first one, and then 600 minus 240, which is whatever left in the second one. So that pretty much means that it's just going to be, then we're just going to add 200 plus, let's say, 400 to get 600 again. So instead of just doing all the steps, we just know that the total amount of mixture in both containers, in the large container, sorry, is going to be 600. So you can do 600 for the first one, which is because there's water and orange juice, a mixture of 600 milliliters in the first container. And there's going to be 600 in the second container. So in the large container, there's going to be a total of 600 plus 600 milliliters. And the amount of orange juice is going to be 200 plus 240. So now we just add that up, and we know that the answer is going to be 440 out of 1200. And we can simplify that even more into 11 divided by 30, because 440 divided by 40 And 1200 divided by 40 is going to equal 11 over 30. And this is our final answer. So 11 out of 30, so 11 over 30 is the amount, is a fraction of orange juice in the mixture of water and orange juice in the large container. Now let's move on to our second challenge problem. So we're going to compute 2 times 1 minus 1/2 plus 3 times 1 minus 1/3 plus 4 times 1 minus 1/4, and we're going to keep going all the way till 10 times 1 minus 1/10. So let's look at some patterns in this question. First of all, this is successive. It's going to be 2 plus 3 plus 4 plus 5 all the way up till 10. And this is also successive. 1/2, 1/3, 1/4, 1/5, 1/6. It'll keep going all the way to 1/10. So now let's try to find another pattern by solving the first part of the expression. So let's look at this. We are doing 2 times, and then we do whatever's in the parentheses first. So what's 1 minus 1/2? Just 1/2. And if you know multiplication, we know that it's just 1 times 1 over 1/2. And then we know you can just cross these out. We can just do this. 2 over 2, what is that going to equal? 1. Now we could do this. 3 times, it's going to be 2 over 3. So if we do that all the math, we get 2. And then we're going to do the same thing here. 4 times 3 over 4. It's going to equal, do all the math, and it's going to equal 3. And let's do the last term too. So 10 times, it's going to be 9 over 10. And our answer is going to be 9. So if you notice, it's always going to be the numerator of whatever we're multiplying by. Alright, so now that we've established another pattern, we can see, now that we've solved some of the questions, some of the expression parts, we can see that the answers are also successive. So they have 1, 2, 3, 4, 1, 2, 3, 4, and you'll keep going 5, 6, 7, 8, all the way up till 9. So what we can do is, since we already know that this is 1, this is 2, this is 3, this is 9, we can just do this. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. And then we know that equals 45. And that is our final answer. Thank you so much for watching this video, and I really hope you enjoyed it and also learned a lot from it. And please don't forget to like and subscribe. It'll really help us a lot. Maybe even leave a comment down below. Thank you.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!